Alright guys, welcome to the non-calculator study guide. So everything in here you should be able to do without the use of a calculator. I will also upload the calculator one separately. I just want to remind you that this is not necessarily indicative of exactly what's going to be on the test. Okay, the test is longer and it has different kinds of problems sometimes. These are just leftover problems, so they're not necessarily to give you a feel of the test specifically. It's more to give you a feel of what kind of tricky questions they can ask, okay? So like this first one, for example. This is an FTC problem, except for they don't give you the bounds, but they give you the answer. Okay, so that's one way they can mess with it. If I was going to say there's a theme of this unit, it is the fundamental theorem of calculus. Okay. If you don't know the fundamental theorem of calculus, you probably will not pass this unit. It's got to be analytical, numerical, graphical, and word problems, okay? You will be using the FTC all the time. So if you're uncomfortable with that, get comfortable because we're going to be using it a ton. So for this first problem here, it's straightforward FTC problem, or so it looks. Okay, so you start with taking the antiderivative. So I get x squared minus 2x from k to 2. And the mechanics are the same. We're just going to do f of b minus f of a. But in this case, a is k. And when you do that, it's equal to negative 3. There we go. All right, so we have 4 minus 4, well that whole thing goes away, minus k squared plus 2k equals negative 3. Now you'll notice the squared means it's a quadratic problem. And you guys actually know how to do these from sophomore year. Plus 3. Adding the 3, setting it equal to 0. Remember, you can only factor if this is equal to 0. Okay, pull out the negative. And factor. So we have k minus 3 times k plus 1. So my answers are 3 and negative 1. Okay, and it asks for just one of the possible answers. And that's why it's D. All right. Part 2, okay, or number 2. A function has a derivative that's positive, therefore increasing. And its second derivative is negative, therefore it's concave down. Okay. So increasing and concave down can look like this. Okay, it's increasing, but it's facing down. And they ask us to do 3 different ones: left, right, and trapezoid. So we'll look at all 3: left, right, trapezoid. So for a left-hand side, okay, that's the first one we learned. You go to your left hand and draw a rectangle. Okay. For area underneath the curve, that looks like an under approximation to me because of these blank spaces here. Okay. Then, for a right-hand Riemann sum, okay, instead of starting on this side, you're going to start to the right and draw your rectangle that way. And to me, that's an over approximation because look at all this overhang you have here. And then lastly, we have a trapezoidal, okay, which is harder to see. Okay. But it's under, okay, because there's just a little bit extra right there. Okay. So we look through the answer choices. Oh, that's under. Left hand is over. No, we said it's under. Right hand is over. Yes. Okay. Trapezoidal's over. No, it was under. And then D is just the opposite of B, so that's not it. All right. Number 3, the issue here is I did not tell you that this was a graph of f prime. Okay. Hopefully it can be surmised, but this is a graph of f prime that I pulled from somewhere. All right. They want to know which of these are true. So if this is the derivative, it's saying f is increasing from 0 to 5. Well, 0 to 5, we notice that f prime is positive. Therefore, the original is increasing. So yes, 1. That means I can count out B and C already. Okay. Point of inflection happens when the second derivative is 0. So we're saying, is the second derivative at 3 equal to 0? Well, let's go to 3. That's at the tippy top of this. Okay, yes, its derivative would be negative because this is the first one. Or not negative, sorry, would be 0. Because this is the first derivative. If we took the second derivative, it would go from increasing to decreasing. Therefore, it would be equal to 0. So yes, part 2. So we're still between A and D. So part 3 really matters. And it's saying from -4 to 0 of f prime, which is this, its integral would be 10.5. Now the thing is, the integral is just the area under the curve. So we're going from -4 to 0. And your instinct is probably find the area of that trapezoid. But you already know that this is not true. Why? Because you know that that area has to be negative. It's underneath the curve. Okay, so 3 is not true, and that's why the answer is A, only 1 and 2. All right, for number 4, they give you, so this one's complicated in a weird way. Okay, so they give you G. They say F is the derivative of G, and then they want the antiderivative of that. So I know it's really tempting to go, oh, well, if it's the derivative and the integral, then we're just back to here. I'm going to do FTC on this. But the problem is, when you take the derivative of G, which is F, you get 2x minus 3. Cool. Well, then we take the antiderivative of that from 1 to 3. You get x squared minus 3x. Okay. The 4 drops off because of that plus c situation. So we have from 1 to 3, and we just do 3 squared minus 3 times 3, f of b minus f of a. Okay. So that's 9 minus 9. Again, that part drops out. So I have -1 minus 3, which is -2, or +2. And I'm guessing that one of these answer choices includes that 4. Okay, so be careful. So the answer is 2 or C. All right, on to the next page. All right, number 5 is a fancy way to ask number 2. So, C number 2. Because this is increasing, and it's concave down. So basically, it's a graphical version of a word problem from number 2. So it's increasing, it's concave down, and they're asking which one of these are an underestimate. Okay, so C number 2 if you still don't get it. But the left-hand Riemann sum, where I start from my left-hand side, that's definitely an under approximation. Okay, we got some spaces here. The right-hand one, where you start from the right-hand side, is definitely an over approximation because of all these blue parts up there. And then the trapezoidal, I should put another color, would basically be connecting these spots, these corners here. Okay. And it is an under approximation just like in number 2. So it is 1 and 3. Letter choice D. All right, speaking of Riemann sums, there's not too many Riemann sums on your test, but they're definitely there. Okay, we're doing another trapezoidal one from 0 to 6 of 3 subintervals. So we're going to go from 0 to 2, 2 to 4, 4 to 6, which is cool because that's equal length. Remember, it's 1/2 height, base 1, base 2. Okay, and the height for each of these is 2, so it's going to cancel. So essentially, you just have 3 trapezoids. So the first one is going to be 4 plus k, okay, base 1, base 2. The second one from 2 to 4 is going to be k plus 8. And from 4 to 6, it's going to be 8 plus 12. Okay, and then we had the 1/2 and the 2 out there, but they cancel. So that's 4 plus 2k plus 16 and 12. Add them up, and you get 2k plus 32 is equal to 52. Right? So it's one of those situations where they did the Riemann sum for you, and they're asking for some missing number. Okay? So now, just use algebra to solve for k. 2k equals 20. That means k is 10, which is answer choice D. All right, number 7. And this is the last multiple choice I have for you on this, okay? I have more on the calculator version. So step 1 is to split it up. Okay, so I have 2 -3 to 1 of f prime plus 3 -3 to 1, bounds are the same, of f double prime. Okay. Again, this is an FTC problem. Okay. But the hard part is knowing what we're talking about. So we have f prime. You take the antiderivative of f prime, that puts you back at f. So that's going to be f of b, which is 1, minus f of a, which is -3. So that's that first bit. The second bit here, okay, we have f double prime that we're taking the antiderivative of. So that means we're going from here to here. Okay, so we're going from f double prime to f prime. So it's going to be f prime of b, which is 1, minus f prime of a, which is -3. Then we just go ahead and solve it. So f of 1 is 7 minus f of -3, which is also 7. Cool. That whole bit's going to cancel. Plus 3 times f prime of 1 is 5 minus f prime of -3. So f prime -3 is -5. So minus -5 is plus, and you get 3 times 10 or 30. Right, so that's a way they can mess with you because it seems really straightforward, right? But you have to know which function they're talking about and to use the antiderivative correctly. All right, so there's only 7 here, but tomorrow there will be 13 on your test, or whenever you're listening to this, on Thursday the 13th, there will be 13 problems. Ooh. All right, and I have 1 free response here for you. Okay, again, on the test there are 2. Okay, just for time's sake, we don't have too much on here. So I've given you f prime, and f double prime, and I gave you some values, 1, 2, 3, and 4, and then what's going on in between. Okay, so they want to know when f of x is increasing and concave down. Well, for f to be increasing, the derivative has to be positive. Okay, so you're looking right here at the derivative, and it's positive between 2 and 3 and between 3 and 4. Cool. But for it to be concave down, okay, this is again like number 2 and number 5 on the multiple choice. It's got to have a second derivative that's negative. Okay, so first derivative is positive here, but it's only negative here. So the answer is between 3 and 4. Okay. And it says justify. This is a good justification. Okay, as if you write it in math, it's still right. Okay, just because you didn't write out an English sentence, as long as it's clear how you got your information, that's good enough. All right. Part B. Other than k is 1, okay, and I want to talk about why 1 is actually an answer. So we're going from 1 to k of f prime of x is equal to 0. Obviously, from 1 to 1, it would be 0 because I'm not going anywhere, okay? And they're saying, well, we don't want that answer. That's too easy. So we have to actually do the FTC. So the antiderivative of f is f prime, or sorry, the antiderivative of f prime is just f. So f of x from 1 to k. and we do f of b minus f of a equals 0. Well, f of 1 is, you just look, f of 1 is 2. And that means I need to know what else would give me 2, because 2 minus 2 would be 0. And if you look, f of 3 is also 2. So if this was f of 3, it would be 2 minus 2, which is 0. So k is 3. Okay. And again, plenty of justification for your answer. Okay, you showed that you know what that means, okay, by doing the FTC, and then you found out that f of k would be 2, and thus k must be 0. Or sorry, k must be 3. Whew. All right, part C, based on this table, determine the value of the integral from 1 to 4 is positive or negative. Now, normally I would do FTC, right? If I had f prime, I would go to f. If I had f double prime, I'd go to f prime. But the problem is I have f here, so I kind of have to think outside the box. I don't have any values. But what I do know is that it's positive, positive, positive. All these numbers are positive. Therefore, it would be above the x-axis, and thus going to be a positive area. And all you have to do is write that in words. Okay, positive. Since f of x is greater than 0 for 1 to 4, then the area above the curve would be positive. All right, lastly, they asked us to sketch a curve and then do some stuff with it. So first, let's sketch the curve. It's really not that bad because it's only from 1 to 4, and they give you so much information. So f of 1 is 2. So 1, 2. I got that information from here. F of 2 is 1. And f of 3 is 2. F of 4 is 4. All right. Now, do not just connect the dots willy-nilly, okay? Let's think about it. We have more information. Here it tells us if we're increasing or decreasing. So between 1 and 2, we're decreasing. Cool. But the thing is, there's 2 ways to decrease. You can decrease this way or this way. Okay. And because my second derivative is positive, I know, okay, that it's going to be concave up. So here it's decreasing, concave up. So it's going to look like this, or some version of that. All right, between 2 and 3, okay, it is increasing and positive. Or sorry, increasing and concave up, because they're both positive. So increasing concave up looks like this-ish, right? It can be curvier or whatever, but it's got to be increasing, and it's got to have that concave up. All right, and the last piece between 3 and 4, it's positive, so increasing, which makes sense because it's got to get from 2 to 4, and negative for the second derivative, meaning concave down. So it probably looks like that. Okay, so-ish, right? So that's what I would be looking for. Then we're going to do a trapezoidal approximation here. So 3 subintervals of equal length, meaning that they're each 1 high. Okay. The first one has a base 1 of 2 and a base 2 of 1. Okay, this little trapezoid right here. And then the second one has a base of 1 and the other base of 2. Okay, another trapezoid, 1 and 2. And the third one has a base of 2 and a base 2 of 4. Okay. So we have 1/2 on the outside. We add them up. 3, 4, 5, 6, 7, 8, 12. So you get 6. Okay. Now, does this appear to be over or under? That is interesting. Okay. So we have these two pieces of over here. and this one piece of under. So it's probably pretty close, and depending on how much you curved it. I said mine was an under approximation. Because these two pieces right here looked pretty meaty. All right, and that is your study guide. Again, your actual test will be longer, and if you stick with me right now, I'll give you a play-by-play on exactly what is on the test, topic by topic. All right, so for the non-calculator portion, I've got 1 and 2. So I got FTC. One of them's analytical with a function, and one is graphical. Okay. They both use a graph, but one is going to be a little more analytical than the other. Then I've got just straight up an antiderivative. Okay, do you know the antiderivative of something? Let's see. Another FTC problem where I give you one of the endpoints, I'm looking for the other. So that involves area. A property of definite integrals, so basically where you can split it. I've got average value. That did not come up on the worksheet or the study guide. So make sure you know how to do average value because that's going to show up even though it wasn't on the study guide. Let's see. I have a word problem about the FTC. Or no, a Riemann sum problem, but in words. A particle motion problem. Again, it includes the FTC. A huge, huge thing going on here. This problem, the only way I can describe it is like the magic square problems. Part A for most of them. Then I've got an area type problem. What else do I have for you? A context problem. So what does this mean in a real world situation? Real world. Okay. And then I've got another FTC problem. Okay. So FTC is huge. And then one more of these contexts in the real world problems. For your responses, I've got 2 of them. Okay. The first one's particle motion. And the second one is a behavior of function problem. Okay. So kind of like the one that we did right now. So the first one's particle motion, the second one is behavior of a function. And for this one, you have to remember your derivatives and integrals. All right. So go ahead and study up, make sure you have this done. Let me know if you have any questions, and good luck. Happy studying.